Friends, you may have read about time travel somewhere. You've also watched a lot of movies that have time travel, like Avengers, Endgame, Interstellar, The Flash, etc. In these movies, it is fictionally depicted that heroes travel back in time, fix all the mistakes, and return, which is awesome. But is all this real? Can we really time travel? Well, that question must have crossed your mind at some point, and maybe you said to yourself, I wish I could turn the clock back and fix the errors I made in ignorance. That is, we all want to travel to the past. That's past travel. Meanwhile, others of us want to learn about the future, to be successful at some point in the future or not. Will I be successful in achieving my dreams and the dreams of my family? Well, time traveling has not yet been scientifically possible, but there are numerous scientific theories that explain that it would be possible. Yes, we could possibly time travel and alter time. Therefore, friends, today's video has been produced after researching on time travel. In this video, we will observe how time is and how we can travel through time if we wish to. Like always, this video will be really interesting, so watch till the end. I am Abdul Hanan, and you are watching your own channel, Info Family. So friends, when it comes to traveling through time, different scientists have different opinions. Some scientists believe that time travel is possible, but others don't. Yes, there are scientists who believe that time travel is impossible. They believe that time is an arrow. Once it is shot from the bow, it never comes back. That is, time moves only in one direction. One of these scientists was Sir Isaac Newton because he presumed time as constant, i.e., time moves equally everywhere in the universe. For example, the speed at which time would pass on Earth would be the same everywhere in the universe. But friends, time does not work that way. The great scientist Albert Einstein explained how time really works. Einstein stated that for us physics believers, past, present, and future are just an illusion. In 1915, Einstein introduced his general theory of relativity, a theory that makes us believe that yes, time travel is possible. With this theory, it is proven that space and time are one entity. Theirs not separate, but one and the same, and they are called space-time. With the general theory of relativity, space-time is like a fabric. The more weight you put on it, the more it bends. Einstein described space-time as a piece of cloth, and instead of weight, he showed gravity tugging at it. The more gravity, the more space-time will curve. Let's have an example. Imagine a piece of cloth is space-time, and we place three objects on it: the Sun, Earth, and Jupiter. The Sun has the greatest mass and gravity, so it must have the greatest curve in space-time. Jupiter creates the second largest curve because its gravity is weaker than the Sun's, but stronger than Earth's. Earth creates the smallest curve because its gravity is weaker than both. In short, the stronger an object's gravity, the more space-time curves, which we call space-time curvature. The more space-time curves, according to Einstein, the slower time moves. This is called time dilation, time behaving differently. If you're not familiar with time dilation, let's dive into it in detail. Guys, if I had to provide you with the ideal example of time dilation, I would definitely use a black hole. A black hole is an area with the universe's most intense gravity, so intense that it curves into a singularity. Now, what is a singularity? Let's deal with that first. A singularity is a location where gravity becomes so powerful that it forms an infinite curve in space-time, a curve with no end. The extremely strong gravity of a black hole forms this never-ending curve in space-time, and we call it a singularity. Essentially, a black hole's gravity defies all of physics' laws, and because the space-time has such a high level of curvature, time moves very slowly there. For example, if you spent a couple of minutes near a black hole and then returned to Earth, hundreds and thousands of years might have elapsed on Earth. For you, it's a couple of minutes, but not for Earth. We dramatize that concept in our movie Interstellar, a huge blockbuster science fiction film directed by the acclaimed Christopher Nolan. In the movie, NASA sends an ex-pilot named Cooper on a mission to find a planet in the universe where humans can survive. During the journey, Cooper and his team go to a planet near a black hole. When they arrive, Cooper orders, "Don't waste time here because 1 hour here equals 7 years on Earth."
Go, 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 hurry up!
1 hour here is 7 years. Don't waste a moment. Alas, they don't accomplish anything. When Cooper gets back, his daughter has grown old. and he watches her die before his eyes. Cooper was only near the black hole for a few days, but to his daughter it took a lifetime. That is what we call time dilation, and it is most dramatic near a black hole. Bye. I've already made a detailed video on black holes, and you'll find the link in the description and on the end screen of this video. Let us go back to the topic. Einstein's general theory of relativity teaches us about space-time curvature and gravity, which in turn explains singularities and time dilation. I hope you now understand all this. Let us move ahead and talk about how time travel might be feasible. When you discuss the possibility of time travel, it can be done, but only forward through time and not back. It's either extremely difficult or utterly impossible to go back in time. Why? I'll explain. This is the thing. When we travel back in time and we change something, then our future would have changed. And if our future changes, then we might never be able to return to it. That's a little bit tricky, I know, but don't fret, I'll go on. So that you will understand past travel, there are many examples, but the one most familiar to everyone is the grandfather paradox. It states that if you had gone back in time and killed your grandfather as a teenager, then you'd never have been born. If you were never born, then how could you go back in time? And if you went back, then how would you come to the future when you are not there? So in this case, you would travel to some other timeline. The alteration of the past would alter the future, and if you've altered the future, then maybe you cannot return there. You might end up in some other parallel universe. If still you don't get it, watch the Flash movie. It does it very well. In the movie, when the Flash realizes he can travel faster than light and go back in time, he travels back and rescues his deceased mother. When he returns to the future, he is in a different timeline where his mother is alive, but all kinds of things happen that shouldn't. By tampering with time, he gets stuck in a different universe, or multiverse. If you don't know what the multiverse is, go check out my video on it. I have explained it thoroughly there. I'll put the link in the description and the end screen. Thus, friends, past time travel is complicated, and that's probably why it's almost impossible. Since we can't travel back in time, let's talk about future time travel. Future time travel is possible, but the question is, how? How do we travel to the future? Well, friends, the answer is that we're already traveling to the future. We are all time travelers moving at a speed of 1 second per second. 1 second each second, we move 1 second into the future. Now, if we could move an hour in 1 second, that would be another form of future travel too. If you search it up online, some sites might have 2 methods listed, some 5 or even 10. But calm down. I'm going to tell you the selected methods in this video that actually make time travel feasible. Having read tons of articles, I asked ChatGPT to give me methods for reaching the future that are actually practical. It gave me 4 methods that actually worked. So let's proceed and discuss them. Einstein left us not one theory of relativity, but 2, the general theory of relativity and the special theory of relativity. The general theory explains gravity and space-time curvature, which we've already discussed. The special theory explains the speed of light and relative motion. The special theory tells us that if we travel at the speed of light, time would slow down incredibly for us. How? Let's see. Suppose you are on a spaceship and you are moving at the speed of light. If you were to stay an hour in this spaceship and come back to Earth, years could have elapsed on Earth. We'd be leaving time way behind when traveling at the speed of light. It takes, for instance, 8 minutes for sunlight to reach Earth. But if a person were to travel on foot from Earth to the Sun, ChatGPT informs us, it would take 3,500 years. If he or she traveled at the speed of light, it would take 8 minutes to get to the Sun, covering 3,500 years worth of distance in 8 minutes and getting there 3,500 years early. Making the return trip too would also take 8 minutes, so they would cover another 3,500 years. Then, when they returned to Earth, it would be 7,000 years later. For them, it would be 16 minutes, 8 there, 8 back, but for Earth, it would be 7,000 years. This is time dilation, courtesy of speed. In the general theory, time dilation was caused by gravity. In the special theory, by speed. At the speed of light, we can't yet travel, but if we could see into the future. Time travel is also possible using gravity. I've already mentioned that, but bear with me. The general theory of relativity asserts that the stronger the gravity, the slower time moves. I've mentioned this before, but as I said, the strongest gravity in the universe is at the center of a black hole, called the event horizon. The gravity there is so intense it swallows up even light, the universe's fastest object. This begs the question, if gravity swallows up light, does it mean gravity is the universe's fastest thing? If so, then why do we call light the universe's fastest thing and not gravity? The answer is in Einstein's special theory of relativity. According to Einstein, light is the universe's fastest thing. Here's why. Gravity does not travel and is not constant. It varies from location to location. Some locations have strong gravity, others weak. Light, however, travels and is always constant at 300,000 km everywhere in the universe. That's why we use light speed to measure everything in the universe, such as planets or galaxies being so many light years away. Back to the subject. A black hole's gravity devours light, and its intense gravity results in intense time dilation. Black holes are thousands of light years away, so they're out of reach for now. But if we could travel near one and back to Earth, time dilation would bring us to the future. We also can time travel using hibernation. What is hibernation? Let's know. Hibernation is rest or deep sleep, typically found in animals. When it is extremely cold, certain animals go into deep sleep to survive, called hibernation. In hibernation, their body temperature falls, and processes like breathing, blood flow, and heart beating slow down. This is what they don't feel hungry and can go through winter without food or water for several months. Hibernation has not been done yet in humans, but if it could be done, it might be something like this. People would be housed in big machines, so their metabolism would slow and they would be able to go years without eating or drinking. Because metabolism would be slowed, aging would as well. If you hibernated for 10 years, it would be equivalent to 10 hours for you. Slowing down aging would enable us to travel to distant galaxies. This might even enable us to travel to Mars. SpaceX has been working on Mars missions for decades, figuring out how humans can survive there. Typically, a spacecraft will take 6-9 months to Mars, and feeding individuals, providing them with water, and provisions for all that time is really hard. Hibernation can slow human metabolism down to low gear, which would enable us to make a journey to Mars. The concept of wormholes is fantastic. Wormholes are the space-time shortcuts, and they would actually enable us to travel billions of light years in seconds. How? Well, let me explain. Think of paper with point A on one end and point B on the other. To move from A to B, you would have to go the whole distance. But if you folded the paper in half, A and B would meet, and the distance would cease to exist. A wormhole works similarly. Here's another example. Our galaxy, the Milky Way, and our closest neighbor, Andromeda, are 2.5 million light-years away. Traveling at the speed of light, it would take us 2.5 million years to get there. Now imagine a wormhole forming between them. How long would it take to get to Andromeda? Years? Months? Weeks? No, seconds. A wormhole is a tunnel through space-time that could potentially compress millions of light-years into a few seconds. In an interesting twist, wormholes are hypothetical. No one has any idea if they exist. Einstein predicted them, and his prophecies usually prove to be true. He didn't explicitly refer to black holes, but he did discuss singularities, which suggested them before they were discovered. If wormholes do exist, they might allow us to travel enormous distances in an instant. This concept also arises in Interstellar, when NASA finds a wormhole near Saturn to travel to another galaxy for a habitable world. I recommend you view Interstellar yourself. It addresses time dilation, wormholes, black holes, and even the fourth dimension. At the end, when Cooper travels into a black hole, he reaches the fourth dimension and sends communication with his daughter. Those are the 4 methods to travel to the future. They are not yet possible, but if they become possible, we might surely travel to the future. Scientists believe that although we cannot travel to the past, we can see it. How? Let's find out. We all know that dinosaurs had roamed our world 200 million years ago. Picture an alien 200 million light years away staring at Earth. Because they are 200 million light years away, they would not be seeing Earth the way it is now. Instead, they'd see it as it was 200 million years ago, complete with dinosaurs roaming. Why? Let's investigate. When sunlight reflects off of Earth, that's what makes it visible. That reflected light will continue moving through space indefinitely. To the alien 200 million light years away, only when that light reaches them does Earth become visible 200 million years later. If they possess super advanced technology to look at Earth from afar, they'd be looking at the light that reflected off 200 million years ago, showing dinosaurs. This is called look-back time, and it's no joke, it's science. I have tried to describe it in depth, but if you're still not getting it, you can ask ChatGPT or Meta AI to explain in greater detail. Look-back time is a fascinating subject, and NASA's James Webb Space Telescope demonstrates it. The James Webb is NASA's most powerful telescope to date, and the one thing that blows my mind is that it can observe the past. How it does it is yet to be researched, and I'll be releasing a special video on it in the near future, examining what the James Webb has observed.